Variables and factors in experimental design. In this video, we're going to cover the core components of experiment design, from experimental objects, tasks, processes, levels, and conditions, to the various kinds of experimental factor that make up an experimental design. Let's imagine an example experiment where we wish to measure how quickly somebody can move a cursor on a screen towards a target. And we want to compare different kinds of input device, such as a mouse, joystick, and a trackpad, as well as compare the impact of different sizes of targets. Let's outline the core components of this experimental design. First, the experimental objects. These are the objects that are used in the experimental design. For example, the monitor with the cursor and the target is an experimental object. The input devices are also experimental objects, such as the mouse, analog stick, and trackpad. Additionally, the software or stopwatch we use to capture how long it takes the cursor to reach the target is another experimental object. What about tasks and processes? This is the procedure that takes place during the experiment. For example, the experimental task in our experiment is the participant being asked to move the cursor towards the target. Now let's identify the experimental factors or variables of our experiment. These are the parts of the experiment which can vary or change. An experiment design has two key types of variable identified by the researcher: the independent variables, or IVs, and the dependent variables, or DVs. Independent variables are variables that are controlled by the researcher. Think of these as the inputs to the experimental system. In our example experiment, the independent variables are which input device the participant is using, be it a mouse, an analog stick, or a trackpad, as well as how big we make the target, be it small, medium, or large. Dependent variables, or DVs, are the variables which may change depending on the independent variables. This is the output or the result of the experiment, the data that you collect. In our example experiment, the dependent variable is how long it takes the participant to click on the target. The goal of an experiment is to observe what impact, if any, changing the independent variables has on the dependent variables. For example, in our experiment, we want to know whether the input device the participant uses, be it a mouse, an analog stick, or a trackpad, has an impact on how quickly they can move the cursor to the target. We also wish to know whether making the target small, medium, or large has an impact on how quickly they can click it. The different possible values that an independent variable can have are called levels. In our experiment, we have two independent variables. The first is the input device used, and there are three levels: a mouse, an analog stick, or a trackpad. The second independent variable is the target size, and again we have three levels: a small target, a medium target, or a large target. Each unique independent variable combination is called an experimental condition. If there is only one independent variable, then each level is a condition. If, however, there are multiple independent variables, then each unique combination of independent variable levels is its own condition. For example, in our experiment, we have two independent variables with three levels each. This equals 9 total unique combinations. In a perfect experiment, the only changing factors would be the independent variables controlled by the researcher, allowing their impact on the dependent variables to be perfectly observed. We can see how the dependent variable changes depending on how the independent variable changes. In practice, however, other factors also exist which could impact an experiment and dependent variables. Let's consider confounding factors. These are factors which are identified after the experiment has been conducted, which could have impacted the dependent variables, but they are not independent variables that were being systematically varied by the experimenter. This throws the results of the experiment into doubt, as it is unclear if the changes in the dependent variable are due to the independent variables that we varied on purpose, or due to some confounding factor that we had not considered. Let's say, for example, that after we conducted our study, we discovered that the cursor sensitivity was varied between participants. This would have impacted how quickly the cursor could be moved to the target, which is the dependent variable we are measuring. Because of this confounding factor, we now cannot be sure how much of the difference in the dependent variable, the speed of the task completion, was due to the input device, such as using a mouse or using a joystick, or how much of it was just due to the different cursor sensitivity, and this invalidates our results. To counteract this problem, any possible confounding factors that are identified before the experiment are set as constant control variables. Control variables are variables which we have purposefully decided not to change and to hold steady, as if they were allowed to vary, then they could have confounding effects. For example, if we might decide to conduct our study again, having identified the problem with the cursor sensitivity, and this time we'll keep it constant so that it can't impact the results. The final type of variable to discuss are random variables. These are factors which could impact your dependent variables, but that you deliberately decide not to control. Allowing these variables increases the generalizability of the results. In this example, even though the participant's age could impact how quickly they could move the cursor and click on the target, by allowing a range of ages into our study, we can then say that the results of our study will apply to a range of age groups. When comparing confounding factors to random variables, we can see that both are variable factors which could have some impact on the results, but random factors are identified beforehand and are chosen not to be controlled, allowing the results to be more generalizable. Confounding factors, on the other hand, are identified afterward and could have had an impact on our dependent variables, casting doubt on how much the independent variables that we chose to vary have impacted the results. It could have all been down to the confounding factor instead. So let's summarize the core components of an experimental design. Experimental objects are the objects or artifacts that make up the experimental design or the apparatus. These are the objects from which the experiment is built. The tasks or processes are the procedures or processes or actions that take place during the experiment. The outcome is observed by the researcher. Independent variables, or IVs, are variables intentionally varied by the researcher to observe what impact they could have on the dependent variables. Dependent variables are the output or the data of our experiment. The experiment is designed to observe how these variables will change in response to different independent variable levels. The levels of an independent variable refers to the different unique values that it can have. Each unique combination of independent variable values is a unique experimental condition. Confounding factors are identified after the experiment is concluded. They could or did have a result on the dependent variables. This makes it hard to gauge how much of the dependent variable change was due to the independent variables, as it could have been due to the confounding factors, and thus makes it hard to draw any conclusions from the results. Control variables are identified beforehand and are kept constant in order to prevent them from having confounding effects on the experiment. Finally, random variables are identified beforehand and could have an impact on the dependent variables, but are allowed to vary as they increase the generalizability of the results of the experiment.